Okay, in this section we are going to answer the ancient question if the prom is actually a monad, and I will claim that the prom is actually a monad by design, and there is the promise resolve is equivalent to an either right, the promise reject is equivalent to an either left, and also the either bind it's equivalent to a promise then. So the promise then acts as a monadic bind. The designers of the specification actually designed it like in this way, and I'm not sure the history behind that, if they are familiar with the concept and that was intended or it just emerged. So let's go right here and try to see why this is actually true. So if we have, for example, I will go here and have an example of the either bind where I have a right and then I have a series of binds and a pattern match at the end. So we know that we have a right, then if I change any of the rights into a left, then the computation should stop at the first left, including the computations at the first left. So if I put left here, I should have 1, then increase here by 1, so it will be 2, the value will be 2, 3, and I will reach here, I will have a 4, and then at that point, doesn't matter what comes next, the computation stops here and we will reach this case. So if I run that, what I should see, let's go here and have a 4. And that doesn't affect, so if I have a left here or here, I still reach here with the first left value. So you should still reach here with a 4. And if everything is right, we already know that we'll reach the end of computation here. In this case, the right pattern matching, and there will be the full values will be 1 plus 1 plus 1 plus 1. So if I run that now, I will reach this case and the value will be 6, which is correct. So that's an either monad operating. Now I can go here and replace all the rights with promise resolve. I will copy and paste the equivalences. So those are the isomorphism between a promise and an either, as I claimed. So I'll copy that here. So we'll have I will replace the then catch pair with the pattern match, either like pattern match, and then we said that the then behaves as a map and also then behaves as a bind. So those three statements here represent the isomorphism between promise and an either. So if I have this statement here, I assume that I will reach the right and the v will be 6 like our previous case. So if I run that, you see that we are reaching here and the value is 6. So in this case, the promise actually resembles the either. Now, if I go and rename I replace reject here, so this is like an either left, I should go and reach the left case with 1, 2, 3, 4, 5, and the error should be 5, right? So if I run that, I reach here with the correct value of 5. And also it doesn't matter if any subsequent bind is a promise reject, so I will still expect I still expect to reach the left with the first reject value. and if I run that, I see that, yeah, still 5. So this means that in every case the promise resolve with those conditions behave exactly like neither async, like a neither monad. So this concludes this lecture. In the next lecture we'll see a more practical example, and then we'll see two examples, and we'll factor our previous either monad examples. So see you in the next lecture.